Hi, I'm Pagata12 and today we play with matrices once again. This time we multiply them with a set of vectors. So we'll have a bunch of them, and this requires some texture specific computations and tricks. And yeah, right here I have I hope it's a last proof. This matrix right here multiply with this vector. I kept the numbers from my previous tutorial with and I go into chops, and yeah, I have the texture, but it's flipped, and here I see it with normalized split just to check 5 7 8 2 3 1 4 9 2. So yeah, we are good. And here we grab the columns, obviously, and here we have the vector, which is a RGB. We have 7 to 1 on RGB channels, and we multiply by those channels, and then we add the channels together. So, and yeah, we need this flip only if we want to use the same group method. Like here we group columns, and yeah, if we want in the end to group columns and get to the result, then yeah, we use this flip. If not, we group rows. Okay, and yeah, let me show you with colors. With colors, I name those dummy colors. So I have a noise, I treat it like a matrix, and yeah, I grab the columns, you see, and place them into RGB. I multiply with a vector, and here I have my result like a column vector. Okay, now I would like to have it like a pixel, right? So this flip with the flop top left, it's necessary if I'm grouping you see, like this. But if I'm using the opposite group, okay, I'm grouping with the bottom top instead of left right, then I can have a result right here. And this is maybe a discussion about how you want to have this, okay? And yeah, it's becoming much more complex when you want to treat many vectors. Okay, just imagine you can't flip that anymore because it has a lot of neighbors, and you need to flip inside a cell. Okay, and yeah, it asks for some little tricks, but I would like to show you what I did wrong, right? In the old example of mine. So I have this cube. I can rotate the cube, okay? And I go inside here. As I said, this is similar with this. Now have in mind we take a bunch of vectors, okay? So this is much more complex than just grouping, okay? And what I'm doing here, it's something, it will be very useful in this new implementation, because we gain 2/3 better optimization. So yeah, and I will draw you what's going on here, and the method that I use, it's yeah, it's looking very similar, rows and columns. And when I wanted, because this is an old file, and I wanted to prepare it, okay, to make it new again, and I make a big confusions about those two, and I said, okay, they look similar, they are similar, and let's make them similar. So what I end up with was grabbing different numbers, and in a scenario of some rotation matrix where you have a bunch of zeros, they can multiply and disable each other, annulate each other, and the result would be not so visible wrong, okay? But in a case you go into composite matrices, in such those zero places were not there anymore, then some errors may appear. So yeah, so this was my first example, and it has this thing, multiplication with identity matrix, and I'm not treat this as a matrix necessary, but yeah, the challenge when you compute for more vectors, each vector having 3 pixels in a column vector, right? 3 pixels. So let's call that a cell. We have a bunch of cells, and so we need to either grab values from there or maybe flip the cells, okay? And yeah, now I want to before we start here, I would like to show you the challenge. Okay, so you might have this cell, okay, and many other near, okay, it's a grid, and you want to flip it like this, and flip operator will not work. Obviously, we have a grid of those cells. So how you do this? What I was thinking is using a square, right, with those, and then because I have only 3 numbers, what if I place those 3 numbers on this diagonal, okay, and everything else set to 0? So you see, this is where that identity matrix come into play. Okay, I'm just using it as a white diagonal. Once I have that, I can go with the pixelate. Okay, and pixelate, I take the this region. Okay, so sorry. Okay, when I pixelate, and then everything become the average of those 3 pixels. Those 3 pixels average. Okay, but here I have 2 zeros. Okay, so I decide, okay, I do the average, and then I multiply with 3. When I multiply with 3, my average, it becomes this pixel, this value. Okay, so then with a fit, I can go either into vertical or horizontal. So it depends, right? And yeah, this is the method that I use. And now I will show you a different method. Okay. And yeah, I could start with some rotation matrix or something, but yeah, maybe it's easier to see with identity matrix. So what we do here is I multiply an identity matrix with a vector, and the result should be exactly that vector. So identity matrix doesn't do anything, okay? But sometimes it's easier to see. So what I'm doing here, okay, I have this matrix 0, 1, and yeah, I grab the columns, okay? And now if I check those values, you see here, would be much more visible on a real matrix, but here the values are from the rows. So it's a bit tricky. We grab the columns, okay, and we place them above each other in a RGB level, but then a pixel it's here, and it has the values from the rows. So have in mind it might be a little bit tricky, okay? So I want to multiply this. Once it's in a RGB format, we take each column and yeah, place them in a RGB, and I multiply them. But first, yeah, let's make some room. So I need 3 pixels for each of my vectors. So I do that with a fit here with a group to place the matrix in a RGB format for each of the the vector, okay? And I do the multiplication and the math, and I'm done. Here I have the result of the new column vectors, but I would like to see them as pixels, as colors, okay? So we need to flip that in order to use the same component. It's not actually the same, because you see in this case we have a bunch of them. So just imagine this one would be a little bigger. But first let's see. In case I want to use the same component in the end, okay, I need to solve this this flip. Now this flip is covered, this type of flip, it's covered in some other tutorials. I call it remap tool, because remap tool is needed in order to remap this texture with an RG1 that knows where to place cells in a new orientations. So here the 3 pixels, okay, on vertical are here, 3 pixels on horizontal, okay, keeping the top one to the left, okay. So let's go inside. This is the texture that we build, right? And yeah, it's done with my method I showed in a remap tool, a kind of a scissor. So I'm connecting something with colors on cells, okay, and then I group them and arrange them and do everything. And when I'm finished with the new arrangement, I just plug in a UV, and then I have an image and I analyze the red and the green. And the question is, can I build a procedural channels red and green like there? Okay, so yeah, I have this texture. Now if I remap, you see I flop with top left each of the cells. So and now let's transform them into RGB. Remember, we can't group here on columns, okay? I mean, yeah, because we have a bunch of columns, not only 3. So we need to grab, to harvest, I like to say, the first pixel, the 4th pixel, the 7th pixel, the 11th pixel, you know, you see the jump, only to grab the reds, okay? And then the next one to them would be greens and blues and stuff like that. Okay, let's go here. What I did, this is the input, okay? And here I have a RGB. It's called RGB because previously it was colored, but I believe it's much easier to see like that. So what I want to do is place a white pixel where I have RGB, okay? And I have those 3 channels, 0, 1, with which I can mask what I need. So this switch it's only for visualizing, and it has a bad name, axis, because previously it was colors, so RGB. But yeah, it's better like this. And now I multiply with the incoming texture. So I have the situation where, again, the pixelate with average and the multiplication for the sum, it's a very, very nice method in textures. So if I average those first 3 pixels horizontally, okay, you see, then the result I multiply with 3, and it's this first pixel. Okay, I can have it here. I reorder RGB, and with the fit I'm good. Now I have here exactly those colors, input colors, okay? Because the matrix that we used doesn't do anything, okay? So yeah. But what if we plug in the matrix shaped by a tool, a very dummy tool I done, which, yeah, let me show you. First, let's see, we have those 3 matrices, and with a switch, I have a switch, I can decide which one it's picked. And when I shaped them, I saw this cluster on diagonals, so this cross, let's say, cosine sign with minus, and then this cross is expanded or displaced in a sides, but here on a z-axis it's again together, and yeah, I thought, what if I build such a thing, okay? And I have this cluster, and when I need it, I just multiply with minus on when I need it, okay? And yeah, I make the room in the middle for the case for the rotation on y-axis, okay? Everything else, yeah, here I'm adding what it's missing, you know, and yeah, let's connect this now. And here we can also check using point transform. So point transform does this for us, okay? But I would like to give different vectors different angles. So here it's a second input for weights, and I couldn't find or I couldn't find a way to make this work like proper angles. So yeah, this is why I built this this tool. And here in the point transform, everything is packed in the back, so you don't see the matrices, okay? But it does the same thing, and yeah, it remains this debate if we go with that flop to left or not. I'm not yet sure. And what I want to show you, yeah, it's the rotation. So let's put a lot of them. So I don't know, 48 by 64. Not here. Okay. So now we have a bunch of points, and we rotate those on a x-axis. If we want to change the axis, okay, so it's y-axis, and yeah, this is the way I implemented the matrices multiplication with vectors, and it just work on matrices multiplied with matrices, and even quaternions, and we will get there. And yeah, I really hope you like this. Thank you massive for your support, and I'll see you in the next one. Bye.